This is the second part of the Finding Limits 2 notes. So on the back side of the note sheet, um, what I've got here is all of the notes written out, and I'm just going to quickly talk you through this, and I'm imagining that you'll do some pausing and looking at. So generally, when we're doing notes, a lot of times when x is approximately equal to a, you can just kind of look at it pretty, just do a little bit of thinking, and just the solution jumps out at you. There are three situations where you're going to have to do a little bit more thinking. One of them is when we get something where we have a number divided by 0. And the thing that happens here is when you take a number and you divide it by 0, as you get closer and closer to 0, the fraction here, number divided by something really small, is going to approach either infinity or negative infinity, or it could approach both positive infinity and negative infinity depending on which side it's coming from. So here's an example over here on the left where it's approaching positive infinity on the left and it's approaching negative infinity as you come in from the right. So what you're going to have to do to sort this out is you're going to have to very carefully check from each side to decide whether we got something that's positive infinity, negative infinity, or both. Second example is when you have the form 0 divided by 0. And one of the things that results if you have 0 divided by 0, one of the situations might be that you have a hole in your graph. So as we saw on the front side of these notes, if you do a little bit of algebra to change how the function itself looks, you can get rid of, as I referred to it in class, as get rid of the cancer that's in the denominator, and then that'll allow you to figure out what's going on as you're approaching a. And then the third situation is where your graph has some sort of jump or discontinuity to it, like is shown here on the left. And again, what you need to do is check from each side. So a couple examples here. The first one, a. Here we're of the form 0 over 0, right? So that's of the second form. And this one factors. Notice the trick here is to realize that x minus 9 is a difference of squares, so it factors into the square root of x minus 3 times the square root of x plus 3, and then on the bottom you've got your square root of x minus 3, the cancerous part, and that reduces to that, leaves you with the square root of x plus 3. So as you're approaching, as x is approaching 9, what you can see is this limit is going to be approaching 6. Right? So we're going to substitute, after getting rid of the factor in the denominator by canceling it with the factor in the numerator, then we're left with this. We take the 9, plug it in here, we get the square root of 9, which is 3. 3 plus 3 is 6. Over here, we are in the form negative 2 over 0 when we plug 0 directly in. So this is telling us that, well, this is going to be either positive infinity headed towards positive infinity, or headed towards negative infinity, or maybe heading from positive infinity from one side, negative infinity from the other side. So first we look at it as what's going to be happening as we approach from the right. And if you look at this, the limit as we approach from the right, so we get a number very close to 0 but positive. So this is going to be negative. We get a number over here very close to 0 plus but positive. So this is going to be positive on the bottom. So as we approach from the right, it's going to be negative. As we approach this, as x approaches 0 from the left, again, this is going to be very close to 0, but it's going to be negative. It'll be like negative 0.001 minus 2. This is going to be on the top. it's going to be negative. On the bottom, now this is going to be very close to 0, but it's going to be a negative 0.001. A negative cubed is going to be a negative, so this is going to be negative, and a negative divided by negative is a positive. So this then, the limit is going to be approaching from one side negative infinity. From the other side, it's approaching positive infinity. So what we write is does not exist, and then we explain that by saying it's going to be approaching positive or negative infinity. In example C, over here, bring this all the way up for you. Just walk you through this. So when you plug in 4 in here, this is all the math, and we get into this form 0 divided by 0. So what we're going to try to do is see if we can't get the something in the denominator to cancel out with something in the numerator, so we can get rid of the cancerous part that's in the denominator. So if we factor the top, factoring the numerator is pretty straightforward, x plus 3, x minus 4. Factoring the bottom, we'd like to have a factor that's x minus 4, but then we don't know what this factor is, right? So if this is a cubic, then this is going to be quadratic of some form. And in order to do that, right, we're going to make the assumption that x minus 4 is a factor, which means that 4 is a 0. And then if you notice what I have over here is I've got what's referred to as synthetic division. And in synthetic division, I'm taking the coefficients of the polynomial that I'm dividing, right? So the first coefficient is 1, the second coefficient is -1, the third coefficient is -11, the fourth coefficient is -4, and then the pattern to synthetic division is that I add down, well, this is 1 plus nothing, which is 1. I then take these, multiply them together. 4 times 1 gets me positive 4. I add down again. -1 plus positive 4 gives me positive 3. 3 times the 4 gives me the 12. Add down, -11 plus 12 gives me positive 1. 4 times the 1 gives me 4. I add down again, which gives me the 0 right here. And at this point, when I get 0 at the very end, I know that x minus 4 goes, if you will, evenly into this polynomial. And then these down here are the coefficients of the resulting polynomial. So this x cubed minus x squared minus 11x minus 4 factors into x minus 4, here it is over here, x minus 4 times x squared plus 3x plus 1. Again, the 1, the 3, and the 1 are the coefficients. And then at this point, I can reduce the x minus 4. This leaves me with this. And now I can plug in the 4 and not blow up the denominator. And when I plug in 4 here in the numerator, I get 7. When I plug in 4 into the denominator, I get 29. And then I know that the limit of this polynomial as x approaches 4 is 7/29. And that's the end of, here, make that 7/29. And that's the end of our notes.